6.3, there are two types of problems you're going to work in 6.3, both dealing with dividing. The first set of problems uses the rules that we learned in 6.1. Hopefully we learned in 6.1. For instance, when you multiply with the same base, what do you do with the exponents? You add it. When you raise a power to a power, what do you do with the exponents? You multiply, and when you divide, you subtract. What do you got to do first? Take the smaller one to the bigger one, wherever it's at. Why do we do that? So we don't end up with negative exponents. So very good. Sounds like at least some of you are on board with that. So looking there at example 1 on page 325, you should all be looking there. I'm not going to write the exact problem down up on the board, but change it a little bit, because what they're going to do there is split that up into 3 separate fractions and divide them all separately. So as you're writing your homework problems down, if you wanted to go ahead and do that, that would be fine, rather than write the problem down and then basically recopy the problem. So splitting that up, you'd have 4x cubed y squared on the top. And then they will all be over 4xy. And remember to keep your coefficients and your variables lined up there. So looking again at that original problem where you just have 4xy in the bottom, how many terms do we have there in the bottom? Again, looking at the original, not where we split it up here. But how many terms is this? That is one term. That is a monomial. So when you are dividing a monomial, this is how you do the problem. Later, we will do polynomials, but right now, this is a binomial. So you just split it up and basically simplify each fraction individually. So somebody first said 3 terms, and that's not uncommon. You think 4, the x, and the y are all a term. How do you know that is just one term up there? There's no, exactly, there's no adding or subtracting signs. It's just one number put together there with multiplication. 4xy is just one term. So again, the best way to tell if you're not sure is if there's no plus or minus in there. So then you go back and just simplify each one of those just like you would. This is a problem you would have seen in section 6.1, just that first part. You just have more. So we simplify 4 over 4 would cancel. Now we have x cubed over x. So where's the smallest number? In the bottom, x to the first. You bring that up to the top and subtract, and what would you be left with? X squared. And you can cross those off. Do the same with your y's. Take y to the first up, and what are you left with? Y to the first, or just y. Plus 8 over 4. What would that simplify to? 2 over 1. Now, if you don't have any variables or other numbers other than 1 in the bottom, you don't have to make the fraction. But if you do, then you will. X over x is going to cancel, and you do the same thing with the y's we did in the first one. So we'd be left with a y on the top. Minus 12 over 4 is 3. X squared over x, you'd take the smaller one from the bottom up to the top again, and be left with x. And then y cubed over y would leave you with y squared on the top. So in this particular example, we didn't have anything left in the bottom. All of the smaller numbers were in the bottom. What you always have to check, though, are any of these remaining numbers like terms that you can combine. In this case, no, they're not. Here you have x squared y, here you just have y, and here you have x y squared. Nothing is exactly the same term, so you would be done with that. Look again there on the same page, 325. Another way that they will write these problems down, they will have a negative exponent written out there, if you look at, we will do 1C there. It's the very last row of numbers there on 325. It says 20C to the fourth D squared F. Minus 16CF plus 4CDF. That's all in parentheses, and then over here, I'll write it down. So it's supposed to be multiplied times 4CDF to the -1. So what does that basically mean? Since they have the -1 outside there. What? Right, because what do you have to do with the negative exponent that's listed in the top as that one is? Take it to the bottom. So it's just another way that they are writing this division problem. So it's no different than the first one, but they will write it that way. So just keep that in mind. The other thing, which is the way I'm going to do this problem, you don't necessarily have to write for CDF under each one of those as long as you make sure and divide them all. So if this comes pretty naturally to you, you don't struggle with it very much, you could probably do it without copying that down underneath there. And I'll show you how. So we're taking this term divided by this one. So 20 over 4 would be 5. And then C to the fourth over C, take the smaller one up, C cubed, D squared over D, you left a D to the first, and then F over F. Cancels, so we're done with this term. Minus 16 over 4 is 4, C over C, and then look at the D. Where's the D at? In the bottom only, so it has to stay down there. You don't have any D's in the top, so that D, at least anyway, has to stay down there. And then F over F would cancel out, so now you're done with that one as well. Plus 4 over 4 cancels, C over C, D over D, and F. It's all cancels. What do we have to write there? Not 0. 1. Anything over itself is 1, and in this case you must include that plus 1 out there because all of that canceled. So don't just cross it off and leave it. You have to put a 1 out there if everything cancels like that did. And again, there's no like terms here, so you are done with that. Again, that is dividing a monomial, just one term in the bottom. And next we will go on to, I think we just do binomials in this section. Now, if you look at the next page at the top, example 2, what's the direction say there? Use long division. When was the last time you saw long division? What? 7th grade? That's probably more recent than most. Well, long division that you've seen before would be something like this, divided by, I don't know, be a problem like that, something like that, and you would start the whole process, which you can see there on page 326. They show you how to do that with polynomial. As of today, anyway, I'm not going to cover polynomial long division. It's the first time I've ever not covered it, but there is a method that is much more simple that we're going to cover today, and I don't know if we'll cover long division or not, but the better method is synthetic division. It's unfortunate that you don't have to do long division, because if you had to do a bunch of problems with long division, then you would have a greater appreciation for synthetic division once you see how much easier it would be. So if we had 5x to the third minus 13x squared plus 10x minus 8. And they'll write it several different ways. They might have a long fraction bar, which I guess is how I'll write this one. A long fraction bar, and then x minus 2 underneath there. They also might have it written as just a division and have x minus 2 written out there. So whatever it is, you need to know what you're doing here. So if you were doing long division, you would put that whole thing underneath the divide bar with x minus 2 out front, and you would begin that process. However, for synthetic, you're going to have a little box, or half a box, up in the corner, and what goes in that box is whatever you're dividing by, but you can't put x minus 2 in there. What you have to do is set that equal to 0. And what would you get there? Positive 2. You add the 2 over, and you get x equals 2. Most of you can see that. You don't need to write that step down. You can see that would be positive 2. That's what goes in your half box in the corner. And then on the same row as that, right next to there, you write all of the coefficients out of the problem. You don't have any variables, which is what most people like about this method. Our first term is x cubed. What would the next term down be that would have to be there? X cubed, the next one down would be x squared. Do we have one of those? Yes, the next one down would be x to the first, or just x. Do we have that? And then the next term down would be your constant. Do we have that? So we do have all those terms accounted for up here. What if you wouldn't have had an x squared? What do you think we would put in there? What? A 0. Just like in long division in elementary, if you needed a placeholder, you just put a 0 in. But we don't have any missing. We'll do an example later where we do. So our first coefficient is 5. What's our next one? Negative 13. Must make sure your signs are right. The next one? 10 and negative 8. So that's all you do. That's next step is list those out. Then you're going to skip a line and just draw another line across there. And that's how you set it up every time. You're going to put what you're dividing by in the box and list your coefficients out there, putting a 0 for any ones that are missing. That's how you set up the process. Now, it might be helpful just to watch me go through this problem or go through it with me, but don't be trying to write stuff down. You'll miss a step. First thing you're always going to do is bring down that 5 or whatever that number is, and that goes right there. That's always your first step. Bring that down. Then you multiply these two numbers. What would you get there? 10, and that goes over here. And then you always add down. Always add down. So if we added those numbers down, we would have negative 3, and then you start over. So then you take that number times 2, and you would have negative 6, and then you would add down again, you get 4, and then you multiply it times the 2, you would get 8, and be left with 0. So your answer must have all of your variables in it again, and right now what we've got there has none. So how you put your variables back into this answer, whatever you started with, the highest degree, was x to the third, so the next one down would be x squared, and that's what you put in here. So it's 5x squared. What would the next one be? Minus 3x, and then plus 4, and you have no remainder. Anytime you end up with a 0, you have no remainder. We'll do some problems that do have remainders, but this one does not work out perfectly. So a little bit about where we're heading with this synthetic division, what's coming up later in the chapter. All of chapter 5, we can remember back to, what was our goal with all those methods we used? What were we trying to find? where the parabola crossed the x-axis. Those were all quadratics. So they were all parabolas, and they crossed once, twice, or never. Now we are doing polynomials. We're going to have not just x squared. We're going to have problems where this is x to the third, fourth, fifth, and so on. So what this is going to help us do later is find out where it crosses the x-axis. Anytime that you get a 0 and use synthetic divide, that means that this number is one of the places where it crosses. So that's where we're going with this. After we learn how to do this well, that's what we'll be doing, is finding all the places, because an x to the fifth will cross possibly 5 different times, so you'll have to find 5 answers, and this is how you will do that process. So if you end up with 0, then you know this is one of the answers, it's one of the places it crosses. So we'll do a couple more of these synthetic division problems. X to the third minus 4x squared plus 6x minus 4. And again, dividing by x minus 2. So we put our little box up here. What should go in the box? Positive 2. And then I would always just check and see if you're missing any coefficients. So what's the highest one that we start with? X to the third, which means you should have 3, 2, 1, none. You should go through that process every time. And if you have all those, you're good to go. So what's the coefficient with the first term? 1. The next one? -4. And then? 6. And last? -4 again. So we have 4 coefficients up there. Skip a line, draw a line. Did everybody get that one copied? The ones that I told when I said not to write it? Everybody good with that first one? Okay. So we bring down the 1, multiply that over and get 2. We add down and get -2, multiply across, -4, add down, multiply across, add down. So where's one place that this crazy cubic polynomial crosses? 2. You already know that. So we started with x cubed. This down here is called a depressed equation. I don't know why, but it is. So your depressed equation would start with x squared. So that would be 1 x squared minus 2x plus 2. And again, no remainder there. So that's all your answer is. And now we will do one that will end up with a remainder, so you can see how the answer should look. 4x to the fourth minus 5x squared plus 2x plus 4. And this one is divided by 2x minus 1. So what would go in the little box now? What? Yeah, so on these you might need to set them equal. 2x minus 1 equals 0, add 1. 2x equals 1, divide by 2. X equals a half. Some of you can't see that one quite as easily, but 1/2, positive 1/2 is what goes in the box there. So what's our leading coefficient, or our highest degree? Is a 4. So what should come next? 3. Do we have that? So we know we're missing 1. What should come next? 2, and then 1, and then none. So we got the rest of those. So we do have a 4. That's there. We're missing the x cubed term So we put a 0 in. It's a placeholder. So our x squared term is -5. Our x term is 2. And our constant is 4. So a little side note here. What if we had x to the 5th minus 6? We put it in a lot of placeholders, right? So we put a 1 in for the x to the 5th. We don't have x to the 4th. We don't have x to the 3rd. We don't have x squared. We don't have x, but we do have the constant. So there are a couple problems like that where you just have to put in a bunch of placeholders. So back to our problem. Bring down the 4, multiply over half of 4, add down 2, half of 2, 1, add down half of -4, -2, add down half of 0, 0, and add down again, +4. So we do have a remainder here, and this is where some get confused because they think that's just the last term, that's the 4. Just like we had up here, they think the 4 would be that number. That is not the case. You've got to realize that is a remainder. So we started with x to the 4th, so what would this term be? To the 3rd. 4x to the 3rd plus 2x squared. What would be next? Minus 4x. You always drop down 1. That's why they call it depressed, I think. Because you start with the 4, you always drop down 1 after you do synthetic division. So we have minus 4x. What would our next term be? The constant term. Do we have one? No. So if you don't have a term, you don't have to put a +0 in there. You just got to realize that's your constant term. You don't have one. So you just have your remainder. And the remainder is +4. But that remainder, you have to have divided by whatever you originally divided by. 2x minus 1 in this case. All right, one more, and I think you'll be ready to go. 8x to the 4th minus 4x squared plus x plus 4 divided by, again, 2x plus 1. So what would go in the box here? -1/2. Very good. And we should have 4, 3, 2, 1, none. Which one's missing? 3 again. So we have 8, 0, -4, 1, and 4. Draw our line. And we're ready to go. So we bring down the 8. Half of 8 negative. Half of 8 is 4, and since it's negative, it would be -4. Add down. It's -1/2. So now we have negative and a negative. It's going to be positive, and we need half of 4 again. It's 2. Add down. -2. Half of 2. And it should be positive again. Add down. And half of 2. This one would be -1. Add down. And we have a remainder of 3. So our depressed equation should start with what term? 8x to the third minus 4x squared minus 2x plus 2 plus 3, and the 3 is over 2x plus 1. Homework. We do 1 through 15 all. (16 through 28 even). (29, 31, or just leave 29, 31, and 30.